All right, this is the end of the neuron talk from the module in your book about neurons. And so this is basically finishing up how neurons communicate with each other. Because in the first video I talked about how neurons pass the message along, the different parts of the neurons and the different kinds of neurons, but how do they communicate with each other? Well, neurons communicate with each other over this synaptic gap. It's basically this gap between individual neurons. And so once that action potential reaches the end of the axon, there has to be some sort of message that's sent across the dendrite to the next neuron. And I always think of it as like this guy here that's jumping between the cliffs, okay? This guy is what we call a neurotransmitter. And these neurotransmitters are basically released by the previous neuron and sent over the gap to the next neuron. And the neurotransmitters basically hook on to the dendrites of the new neuron, okay? And so then hopefully if it gets enough and it has a threshold and it gets enough, then it will trigger the next neuron's action potential. So, oh, that's not what I wanted. So what happens is that the neurotransmitters basically tell the neuron what to do, okay? So depending upon what type of neurotransmitter it is, will tell the neuron what it wants to do, the message. So neurotransmitters, different neurotransmitters are going to tell us different things. So there's a lot of neurotransmitters, but there are specific ones that we're going to need to know for psychology. The ones in your book on page 82, the table on page 82, and I have it on the next slide, those are the ones that really we need to know. We're going to focus on those. One of them being endorphins. And endorphins are basically linked to this idea of pain and pleasure, and so they will go and be released, for example, when you're exercising. So if you've ever got to that wall, right, while you're exercising, and you get all these endorphins that will rush through, and you will kind of run through that, okay? So the endorphins are that pain-pleasure kind of principle. Now, neurotransmitters will bind the receptor sites in the next neuron, like I said, and any excess are then reabsorbed in the process called reuptake. So think about this as all of these, like I said, this little guy here, he's our neurotransmitter hopping between neurons, right? So think of the neurotransmitter as a bunch of them hopping between neurons. And it's kind of like a lock and key mechanism, and so there's like basically sites where this neurotransmitter is supposed to land. As soon as all of those sites are full, because they're all hopping, there's multiple neurotransmitters hopping at the same time, once they're all full, there's a bunch of guys that are kind of hanging out there in midair, and this neurotransmitter that released them are going to reabsorb them, okay? That's called reuptake. This is a chart looking at the neurotransmitters that you should know. ACH, we won't talk about a whole lot. We'll talk about dopamine quite a bit, serotonin, norepinephrine, GABA, not a whole lot, and glutamate, not a whole lot either. But the three big ones are dopamine, serotonin, norepinephrine. The other three, yes, they may pop up occasionally, but the big three are the dopamine, serotonin, and norepinephrine. Dopamine, if you have too little dopamine, it's going to have Parkinson's symptoms, so lots of shakiness. And the interesting thing is that to treat Parkinson's, they sometimes try and give Parkinson's patients basically drugs that will mimic dopamine. But if they have too much, then all of a sudden they're showing signs and symptoms of schizophrenia. So that will kind of indicate, okay, we need to, draw back on the dopamine. Serotonin will definitely affect mood, so that's a lot of links to depression. Lots of antidepressants increase serotonin levels. And then norepinephrine is also related to mood, but it's also related to like being alert and awake. So we'll talk about norepinephrine again when we talk about sleep. Okay. So, I forgot to activate this one. Drugs. How do drugs affect neurotransmitters? Well, there are basically two kind of categories of drugs. The agonist drug and the antagonist drug. So the agonist drug is the drug that is going to mimic a neurotransmitter, and it tricks the neuron into thinking it's a neurotransmitter. And so it'll bind the receptor site, and it'll look just like, it'll seem like a neurotransmitter to the neuron, to those receptor sites. So a good example of this is like heroin. Okay, we have some naturally producing neurotransmitters that are very similar to heroin, but heroin will go and basically trick us into thinking that it's this neurotransmitter, and what happens is that the body all of a sudden thinks, wait, we don't need to make any more of this neurotransmitter, and so it cuts back. Well then, if you don't continue your heroin use and you stop cold turkey, you're going to have some major side effects, because you're going to have some withdrawal, because your body isn't producing that neurotransmitter anymore. The antagonist drugs on the flip side are going to block the receptor site, so neurotransmitters can't get through. So curare, if you've ever heard of that, that's a drug. It's a poison. That's a good example of an antagonist drug. Your book has a similar graphic to this, and I really like it because it kind of gives you a good representation and a good picture of it. This one is going to be neurotransmitters, these little green oval things. These are the neurotransmitters, and notice it's kind of like I said, it's a lock and key. So here's the opening that each neurotransmitter kind of just fits in naturally to, and it's the right size and shape, and it just fits. Okay, an agonist drug, notice these blue ones, okay, they are mimicking the neurotransmitter. They're the same shape, they're not the same color, but they'll fit, right? So that's going to be an agonist drug that's going to mimic the neurotransmitter. Whereas an antagonist drug is going to be more like these yellow kind of, I don't know, stoppers, as what you might call it. And so this is the antagonist drug, and they will actually stop, and they'll basically plug up the receptor site, and so then the neurotransmitter can't get through. Okay, that's going to be an antagonist drug. All right, hopefully this was helpful. Let me know if you have any questions. That's it. I'm done.